We're going to start with the first lecture, which is Streaming Data Concepts. Now, what is stream processing and why is it getting so popular? It really depends on data velocity and data volume, which is continuously increasing. We see organizations all over the world that are increasing their data intake. They're wanting to collect as much data as possible, but it's hard to process all of that data on one batch on a schedule. They're finding that what they need to do is try to analyze that data as quickly as possible, and in many cases, as it comes in. This also enables real-time analytics, right? So we can have an organization that's able to respond quickly with actionable insights and make those decisions quicker in a way that keeps up with the current state of data and really the current state of the world. And finally, there's operational applications, right? If you need to provide responses in real time, you need to work with data in real time as well. And that will only happen with streaming data systems. So honestly, the vast majority of data in the world is already streaming data, and it's time for you to start working with it. Here are some use cases, right? So notifications are clearly streaming data. We need to notify people in real time when something is in some specific state or another. And also we have other use cases, including things like incremental ETL, real-time decision-making, and online ML. Specifically, we have a lot going on with artificial intelligence right now, and something like a chatbot needs to be enabled to process data as quickly as possible. What are the advantages of stream processing versus batch processing now in this case? So the idea then is that we have incremental processing of new data, and this is natural and intuitive. It makes sense for us to process data as quickly as possible and do things in such a way that it's fault tolerant, that we can restart the pipeline as needed. It ensures that we have low latency, especially when we have SLAs that call for time-sensitive workloads and low latency. And it enables us to use compute to the highest utilization. If a cluster is already running, we might as well have it be processing data as opposed to just sitting idle. Here's a typical stream processing architecture, and here's how we can also implement this in Databricks. So we have maybe a DBMS or CDC or clickstreams or other app events that might be coming in. This lands messages into a streaming data service, maybe something like Kafka, and these generate messages that need to be processed. And we might push this now into a structured streaming setup using Apache Spark. And this might involve some transformations like window aggregation, enrichment, might be routing to specific tables as opposed to others. And then most data then becomes what we want to have be transactions. So we'll push that data into Delta Lake, where we can perform real-time analytics, triggers and alerts, and other things. And you can see how each of these stages of the process work at the bottom of this graphic here. We have our stream data sources, we ingest, we use a processing engine like structured streaming, and then we have our data storage layer, Delta Lake, and then our query engine where we actually can make sense of that data after it's been pushed into Delta Lake by our streaming system. Here are some of the challenges though, of course, right? Processing data exactly once can be challenging, especially when you have something like a machine failure, right? So what if you have data that's coming in, you have some sort of network issue in the cloud service provider, or maybe you have one of the virtual machines goes down, you have some kind of failure. We want to make sure that we're still only processing each event exactly once. We also have data that might arrive out of order. Right now, event time happens in a specific order, but the data might arrive at the system out of order, and we want to make sure that we're processing based on the event timestamps as opposed to when the data simply arrives. We might push things into an unknown state if we don't worry about that. Now, speaking of state, we also have to maintain large amounts of state, right? We need to know, especially if we are waiting for late arriving data and we want to process that in some specific state, we need to make sure we're processing huge amounts of state. And then finally, we might have a load imbalance, right? We might have stragglers, right? We might have data that's coming in a funky way, so to speak. And we need to make sure that we can update our output syncs when the new events arrive, and how we do that is something that can be very challenging. And then finally, we want to write data transactionally to our output systems so we don't put our output systems in an unknown state as well. What's the solution? Of course, Apache Spark structured streaming, and we're going to talk about that through the rest of this module.